Alright guys, in this video I'm going to talk to you about indexing, and just so we can change things up, what I'm going to do is in my GitHub I'm going to grab this fake bank data, and if I scroll all the way down, I figure instead of just looking at the same hockey data all the time, might as well just switch things up to keep everything interesting. Alright, so this is pretty much, well, it's not really a bunch of users, but it would be like a bunch of users from a bank. So here's a user right now, and what information do we have about them? Their name, of course, gender, what company they work for, a fake email, of course their balance, and all of these are already inside an array. So what we can do now is create the database. So use bank, and of course we can verify that by just writing DB, and it'll display the name of the database, bank. So now we have to insert all of that data that we got from GitHub. So DB, and I'm just going to name my collection users, and we'll just say insert, and inside here we can just paste that array. Looks good, and run this. Alright, so it inserted 35 users or people, and if we clear it, now indexing is one of the best ways to speed up the performance and efficiency of your database. And right now, when I'm just showing you guys these real quick examples, and our database only has like 35 users, or how many players were on the hockey team, like 20, whatever. All of these examples, whenever I run the queries, they're going to go really fast because we don't have that much data. But let's say on my website, I have 40,000 users signed up. So whenever we search for someone, it's obviously going to take a real long time unless we learn about how to, enhance the performance of our database, and that's where indexing comes into play. So first, let me show you a little quick example of the wrong way to do things. So if we just go to DB users, and this isn't really a wrong way, but I'll show you guys how to pretty much do it this way and then how to make it better. Alright, so say that we wanted to find all the users in our bank who were 23 or younger. I don't know, maybe we're having a new like college credit plan. I don't know what banks do, whatever. So we're just gonna hit find, and as you guys know, inside here we can just have any object, and I'll just write like age. We'll say just less than or equal to, actually just less than, keep things really simple, less than 23. So I'm going to run this right now, and it's going to return 2 users. So this guy's 20, or this girl, whatever she is, Rochelle and Dalton. Those are the 2 users in our bank less than 23. Alright, that was pretty quick, but check out what's happening if I do this. I'm going to run this command again, and I'm going to tack on a new method called explain. And what this is going to do is it's going to give you information about your query, about this command right here. So if I type execution stats, this is pretty much just going to filter the results. You really don't need to worry about this right now. I just want to show you guys something real quick. So again, like I said, what this is going to do is it's not going to give you the results of the query. It's going to give us information like how it found the query and stuff like that. Ugh, man, I got like a turd in my throat. I just ate a peanut butter and jelly sandwich. And by the way, I was grocery shopping the other day, and I saw this jelly that you can apparently squeeze from a tube. So, instead of like the jar where you had to stick a knife and then spread it on your sandwich, you can just like squeeze this one from a tube right on your sandwich. So I bought it, and it really doesn't make sense because I already had to get a knife out for the peanut butter to put it on. But I don't know, it's just fun to squeeze jelly from a tube for some reason. Whatever. But anyways, I just ate one of those sandwiches, and now I got like crap in my throat. Alright, where were we? Right here. So it says execution stats. Don't even worry about all this. But check this out. It had to examine 35 results. And that's kind of expected because, let me clear this out. Because remember, we have 35 users in our bank. It's a pretty small bank, whatever. So whenever we have to make a query, such as search for people younger than this age, what it does is it scans through every single document, every single user, and it says, are you younger than 23? Are you younger than 23? And it asks that question 35 times. Alright, well, that seems alright, and it sounds like the proper way to do things. But obviously, once you start getting, hundreds and thousands of customers, like these big businesses, it's going to take a real long time. So that's where indexing comes into play. I heard of this analogy before, and it's actually really good. Indexing in database is pretty much the same way that you index in books. So whenever you're looking for a word in a book, you don't just go through page by page, sentence by sentence, and look for it. What you do is you hop back to the index and, I don't know, say you're reading a book about Mongo and you wanted to look up this explain. You would go to the index, every word is in alphabetical order, you would go to ease, look for explain, and it would say explain on page like 100, 140, and 143. So it's a really easy way of looking for the data that you want to find. A lot more efficient than going through page by page. And that's the same as it works in a database. Pretty much what you're going to do is you're going to index a piece of information. In this example, we're about to index age. And instead of having to go through every single document, every single piece of information, this age behind the scenes is going to be ordered, and then the computer can find it really easily. So how do we do this? Well, we can get rid of this because we just ran it. We're going to say db.users.ensure index. This pretty much just means we're going to give you something, turn it into an index. So what do we want to give it? Well, we'll just give it the age, and 1 just means true. So if we run this, then it pretty much says, okay, created indexes, and I'll show you guys why this says number of indexes 2 instead of 1. It's because if you go to db users indexes, if you just get the indexes, all this is going to do is going to show you what indexes you have. It says, alright, here's the one that we just created. Age is now indexed, and by default, that object ID that it creates for us, behind the scenes, that's automatically an index as well. So let me clear this out, and I'll show you guys something new. Alright, so now what we're going to do is we're going to run this command again, find all of the users who are younger than 23, and whenever we do, if I can find it in my data, alright, total docs examined 2. So I know you guys can't tell because both of those queries, since you only have 35 customers or whatever, they're taking like milliseconds. But if this was a huge database, then you guys are definitely going to notice a big performance improvement. Now if I clear this, anytime you want to get rid or drop an index, it's really easy. You pretty much just, alright, instead of ensure index, you call drop index, and that's going to delete it. So we're going to say drop the index of age, run this, and now I get my indexes. You're going to see that we only have that one index that was given to us by default. So now you're like, alright, obviously whenever I'm making a database, indexing is a lot faster, so why not just index everything? Well, here's the thing. Remember, an index is kind of like having an ordered set of information at the end of your book. And say that your book is 500 pages long and the index is 20 pages, obviously you can find words a lot easier that way. However, if you index everything, what information do we have right here? So we indexed age. Why don't we just index eye color, name, gender, company, email, all of this stuff? Well, that's like adding, 120 more pages at the end of your book. So whenever you index something, it's able to search for that piece of information a lot faster. However, if you think about it, whenever you add a new piece of information, you have to update the indexes as well. So if you just indexed every single piece of information, every single key, whenever you added a new user, not only would you add it to the database, but you would have to update the isActive index, balance, age, eye color, name, all of those. So it would actually slow down your database because even though you might be able to retrieve the information faster, whenever a new customer signs up and presses the submit button, it's going to take like half an hour just to create a new account because you're inserting everything and then updating all of the indexes. So I guess now the only question that you might have is, all right, well then what do I know what to index? Well, generally, again, this is really specific to your application, but generally what you want to do is you want to index only the columns that you search for a lot. For example, if each of these users had a unique ID number, then I would just index that. And then once I found them, I could of course just say, all right, get their other information quick. So you might just want to index their ID number or maybe their name, but definitely not the rest of this information. Pretty much whenever you're searching for users or whatever piece of information, their posts, comments, whatever, you want to index the thing that you can uniquely identify it by, and then once you have it, you get the rest of the information lightning fast. So that's one of the cool things that you can do to speed up the performance of your database. If you don't quite get it, then don't worry. Whenever you're just making a regular website, you really don't even need to worry about indexing. Just when you have, like a huge social network or something, that's when users are going to start noticing the performance. But now I'm rambling. I'm probably going to go eat another sandwich. In the meantime, thank you guys for watching. See you next time.